In this lesson, we're going to be discussing for loops. Our lesson objectives, we're going to recap on what iteration is, learn how to craft for loops, and then learn nested for loops. So iteration is basically any repetition of a process. And in Java, like I said in the previous video, utilizes two control structures that perform iteration. Now, these are not the exclusive control structures that do repetition or iteration, but these are the ones that we mostly use in the APCSA curriculum. And the two are for loops and while loops. And as I said before, the premise of this video is going to be solely on for loops. So the for loop. The for loop is basically a way of getting the while loop, all the stuff that we did on the outside of the while loop, all into one sort of expression. So you know how we had a loop control variable, and then we had to edit that loop control variable within the loop? Well, the for loop does all that pretty much in one line. So we utilize the for keyword to tell the compiler that we want to make a for loop. And then the first expression within the for loop is the initialization. So this is where you're going to initialize your initialize or instantiate a variable, and this variable is going to be your loop control variable. So most likely you're going to have like an integer, and we're going to say integer I is equal to 0. All right, this is the condition to terminate. As long as this Boolean expression evaluates to true, and make sure to separate all these expressions with semicolons because they are Java statements after all. But the second statement is that as long as this evaluates to true, the for loop is going to continue going until it evaluates to false. Then you're probably wondering, how will it eventually evaluate to false? Well, we changed that through an update statement. So you know how in the while loop we had an increment operator, or we increased the value of I to eventually evaluate the Boolean expression to false. Well, we can put that I incrementing thing there. And then we can just simply put our Java statements here without the need of worrying about, editing the loop control variable, because that is done for us within the loop control, or rather the parentheses of the for loop. So just to recap, the first expression, it's for, in the parentheses, is to initialize a variable. Integer I is equal to 0. Then the second statement is the condition to terminate. As long as it's true, the loop's still going. It still goes. If it's false, the loop ends. And then here's the update. The third expression is the update variable, so that eventually the condition to terminate will eventually be false. So eventually, I keep saying eventually, but yeah, eventually this thing will be false because the variable that we use as the loop control variable will be false in this statement. All right, let's look at this example. So for integer I is equal to 0, that's our initialized variable, and I is less than 5. That's our Boolean expression, and then we increment it every single time that the loop executes. So this is the process of executing a for loop. We first declare the loop control variable. So we declare the loop control variable. So it's like integer I is equal to 0. All right, the compiler knows that we have an integer I equals to 0. Then it checks the Boolean expression. Is I less than 5? I is less than 5 because 0 is less than 5. That is a true statement. So it executes whatever is within this Java statement. All right, so it prints out I and then adds a little space there. Alrighty, so it prints out I. I in that case was 0. After it's done executing the stuff or the Java statements within these curly brackets, then what it does is that it goes to the update statement. And it's like, all right, let me increment I by 1. Now, with the while loop, we had it within the curly brackets. With the for loop, we don't have that issue because it's done within the parentheses. So it's like, all right, once I'm done, I got to do this. I is now 1 because we're incrementing it by 1. And then the compiler is like, alrighty, let's go back to the Boolean expression. So is I less than 5? Well, I right now is 1 since we incremented it. 1 is, in fact, less than 5. So we're going to print out I again. I is 1. Alrighty, now let's go to the update statement. I is no longer 1. I is now 2. Is 2 less than 5? Yes, 2 is in fact less than 5. So it prints out 2, and then it increments it again. 3 is in fact less than 5, goes back to the Boolean expression, so it prints out 3. Alrighty, let's update it again. I is now 4. Is 4 less than 5? Yes, 4 is in fact less than 5, so it prints it out. Now it increments I again, so I is no longer 4, I is now 5. It goes back to the Boolean expression, and it finds out that the Boolean expression is now false. 5 is not less than 5. 5 is equal to 5. So this is false, and then the for loop ends. It goes to the next statement if there is a next statement. As you can see, it's usually a process or a loop between the Boolean expression and the update statement. The integer I here is only looked at once because it's first initialized, and that's just simply getting the loop control variable made. This is our main Boolean expression. This is basically the party or the main person, and this controls the whole thing. As long as this thing is true, it's going to keep on executing. And then after every loop has been executed, it has to go through the update. So now the loop control variable is going to get updated within this Java statement over here. So I gets incremented. Alrighty, let's look at another practice problem. For integer I is equal to 0, I is less than or equal to 50, and then I increments by 10. This is just simply saying I is equal to I plus 10. So we're adding 10 to I every single time we update. So integer I is equal to 0. All right, integer I is equal to 0. We've created our variable I. Our loop control variable has been made. Is I less than or equal to 50? Yes, it is. So we execute what's within the for loop. I is 0, so we print out 0. Alrighty, now we go to the update statement. The update statement says we had to increase I by 10. So I is no longer 0, I is now 10, because I is equal to I plus 10, I is equal to 0 plus 10, I is equal to 10. Alrighty, we go to the Boolean expression. Is 10 less than or equal to 50? Yes, it is, so it prints out 10. Then it goes back, increases by 10, so I is now 20. Is 20 less than or equal to 50? Yes, it is. Update again, is 10, add 10, so 20 is now 30. Well, I is now 30. Is 30 less than or equal to 50? Yes, it is. So it prints out 30, prints out 40, and then it prints out 50 because we have a less than or equal to 50. So it adds 10, and we eventually reach 50. Alrighty, it prints out 50. I is now increased by 10, so I is no longer 50. I is now 60. Is 60 less than or equal to 50? No, it isn't. So the program then ends, or rather the for loop ends. If we have any other stuff after the for loop, then that gets executed. So a nested for loop is basically like the nested if statement, right? It's just an if statement, or rather it's just a for loop within a for loop. But you have to be careful when you're doing nested for loops, because you could be evaluating the wrong for loop. You want to evaluate one for loop at a time. So we have for integer I is equal to 1. I is less than or equal to 5. I is then incremented. Alrighty, so that means that we're most likely going to be looping this thing 5 times. And then at the end, and then whenever we loop it, we have a for loop that gets executed within the for loop, and then we print ln statement to make sure that it gets started on a new line. So let's tackle this one by one. For integer I is equal to 1, I is less than or equal to 5, I then increments. So we create our loop control variable. All right, I is now 1. Is I less than or equal to 5? Yes, I is in fact less than or equal to 5. So it executes within whatever is in the curly brackets. Alrighty, so now we have another for loop within our within our for loop. So what we do is we tackle this one by one. Is integer j is equal to I. So I at this moment of the program is 1. So integer j is 1. Is j less than or equal to 12? Yes, it is. So it prints out 1. Alrighty, then it goes to the update statement. Alright, we got to add 3. So j is no longer 1. J is now 4, because 1 plus 3 is 4. Alrighty, is 4 less than or equal to 12? Yes, it is. So it prints out 4. Alrighty, let's update that. Let's add 3. J is no longer 4. J is now 7. Is J less than or equal to 12? Yes, it is. 7 is in fact less than or equal to 12, so it prints out 7. Alrighty. We update it again. It's now 10. J is now 10 because 7 plus 3 is equal to 10. Is 10 less than or equal to 12? Yes, it is. So it prints out 10 because that is the value of J at that moment of the program. Alrighty. Now we got to add 3 again. J is no longer 10. J is now 13 because J is equal to 10 plus 3. So 13. Is 13 less than or equal to 12? No, it is not. So now the program is like, all right, I'm done with this for loop. I'm going to go on to the next statement within the main curly brackets. So we're like, all right, we're done with this for loop. Let's go on to the next line. System.out.println. This basically says to the program, I'm a new line. So whenever there's another print statement that comes up within the program, start on a new line because this line has ended. So if we see through the executed statement, it no longer will be printed because, or would rather not, will not be printed on the same line as this because this println statement states that now we want to start on a new line. Alrighty. So now we go back to the top. Alrighty. So I is now incremented because now we're updating the value after that one for loop. After that one loop of the main for loop, we are now incrementing I by 1. Alrighty. I is no longer 1. I is now 2. Alrighty. So is I less than or equal to 5? Yes, it is. I is in fact less than or equal to 5 because 2 is less than or equal to 5. So it's like, all right, let's execute what's within our curly brackets. For integer j is equal to I. So now j is starting up again. So j was lost after we finished that for loop. So now we're creating a new j. And that j has the value 2 assigned because I at this moment in time is 2. Is 2 less than or equal to 12? Yes, it is. So it prints out j because the value of j at this moment in time is 2. Alrighty, let's add 3. J is no longer 2 because j is equal to j plus 3. So j is equal to 2 plus 3, j is equal to 5. Is 5 less than or equal to 12? Yes, it is. So it prints out 5. Let's add 3 again. J is now 8. Is 8 less than or equal to 12? Yes, it is. So it prints out 8. Alrighty, let's add 3 again. J is now 11. Is 11 less than or equal to 12? Yes, it is. So it prints out 11. Alrighty, let's add 3 to J again. 11 plus 3 is 14. So J is now 14. Is 14 less than or equal to 12? Yes, no, it isn't. In fact, sorry, I lost my train of thought. 14 is not less than or equal to 12. So now our for loop has ended because this Boolean expression has evaluated to false. And then we have our println statement to say, hey, any other print statement that comes later in the program, please do not do it on this line, start on a new line. Alrighty, so now this for loop has ended and this print statement has been executed. So now the for loop, our main for loop, goes back to the update statement. So I is now no longer 2. I is now 3 because we increment I by 1. So I is now 3. Is 3 less than or equal to 5? Yes, it is. So now we got to execute the nested if statement again. So for integer j is equal to I, so I in this moment of time is 3. So we're assigning the value of I to j. So j is also 3. Is j less than or equal to 12? Yes, it is, because 3 is in fact less than or equal to 12. So we print out 3. We add 3 to j, so now it's 6. Is 6 less than or equal to 12? Yes, it is. So it prints out 6. We add 3 again. Is 9 less than or equal to 12? Yes, it is. So we print out 9. We add 3 to j. j is now 12. Is 12 less than or equal to 12? Yes, it is. So it prints out 12. And then it updates it again. J is no longer 12. J is now 15 because 12 plus 3 is 15. Is 15 less than or equal to 12? No, it's not. So we're done with this for loop. And then we tell the compiler we want to start on a new line for the next print statement. Alrighty. So now we go back to the update statement. I is now 4 because we incremented. In this moment of time, I was 3, but now we incremented it, so I is now 4. You can sort of notice how like the value of I based on every single program. So you know how we set j equal to I at the beginning of this for loop? You can see how the value of I progresses through the main for loop. So this is sort of like the main for loop's execution, whereas each individual executed statement here is the result of the inside for loop. Alrighty, so now I is no longer 3. I is now 4 because we incremented it. Is 4 less than or equal to 5? Yes, it is. So we set j, we execute within the Java statements, and we're like, all right, integer j is equal to 4. All right, integer j is equal to 4, so is 4 less than or equal to 12? Yes, it is. So we print out 4. Alrighty, let's add 3 to 4. Let's add 3 to j. J is 4, but now it's 7 because we added 3 to it. So is 7 less than or equal to 12? Yes, it is. So we print out 7. Alrighty, let's add 3 again to j. J is no longer 7. J is now 10. Is 10 less than or equal to 12? Yes, it is. So we print out 10. We increment it by 3 again. So j is no longer 10. J is now 13 because we added 3 to it. Is 13 less than or equal to 12? No, it isn't. So it goes to the print statement saying, hey, we want to start a new line. And then it executes the for loop. It goes back to the update statement. So you tell me, is it going to execute another for loop, or is it going to go on to or does the for loop finally end? And then try to find the values. If the for loop does execute, what are the values that come about? Alrighty, so I hope you managed that. Basically, the end result should be 5. We add 3 again. It should be 8. 8, 3 again. 11. Add 3 again. 14. 14 is not less than or equal to 12, so that for loop ends. And then when we find out that I gets incremented from 5 to 6, 6 is not less than or equal to 5, so it no longer finishes the nested for loop. So it no longer executes that main for loop. And that's basically the premise of a nested for loop. It's a lot of work, and you have to keep track. You have to make sure that you're doing one for loop at a time, meaning that when you're executing a for loop within the for loop, don't try to confuse the variables of this for loop with this for loop, because then it's going to get messy. So try to separate it one by one and try to have it organized such as this way. And this is what the compiler is actually going to execute if you put this Java algorithm within JGrasp or your IDE, for example. Alrighty, so just make sure that when you're evaluating nested for loops that you do the main for loop and then you execute it the for loop within the for loop separately. So as you can see, every line is technically the main for loop's execution, whereas every individual number is the inside for loop's execution. So that's sort of the premise of a nested for loop. You get a for loop within a for loop. Alrighty, so let's do some, I believe, 3 or 4 programs that we can do in Java to sort of grind out for loops and sort of get the premise of what a for loop actually is. Alrighty, so we're in the compiler, and let's create 3 different programs. 3 to 4 programs, depending on the time. So let's create our class, public class for loop practice. Have our open parentheses, or rather our curly brackets, and our end curly brackets. And then let's declare our main method, public static void, main string arguments, And then we have our open curly brackets and closing brackets for that. Alrighty, so for the first program, I want to create a for loop that prints out the values 0 to 10. You could do it, with every integer on a new line, or you could put it all on the same line. So what I'm going to do is I'm going to declare the for loop for integer I is equal to 0. So I've set my loop control variable to be 0 right from the get-go. Then as long as I is less than or equal to 10, then it should print out whatever I want. In this case, I want to print out I. And then after every executed for loop, I want to increase the value of I. And then to print out the value of I would do a print statement. Alrighty, so let's save our program. And then compile. And then run. And then we get the values 0 to 10 printed with our for loop, because our for loop gets executed 11 times since it starts with the value 0. So it gets executed 11 times, and at the end of all those 11 times, I keeps getting incremented. So that's why whenever we print out I within the for loop, its values increase by 1. So I was 0 from the get-go, then it was 1, 2, 3. After every single loop, it increased, so 4, 5, 6, all the way until it reaches 10. The final value of I is actually 11. The reason why is because by the end of this, the 10th or the 11th loop, it's like, alrighty, let me increase I by 1. So I was no longer 10. I was now 11. And then it's like, is 11 less than or equal to 10? And it's finally evaluates the false. So the value of 11 was reached because that will enable the for loop to eventually be evaluated to false. So now, because of that 11, the for loop ends. So now let's make a program that computes the sum of the values from 0 to 10. So in this case, what I'm going to do is I'm actually going to create another value. And this is where we're going to store the sum. And then after every loop, we add the value of I to the sum. We don't make sum the value of I. We add the value of I to sum. And we could do that two ways. We could do sum is equal to sum plus I, so that whenever the loop gets executed, it adds I to the sum. Or what we could do from our assignment operator video is we could just simply put sum plus equal I. And that is the same way as writing sum is equal to the new sum is equal to the old sum plus I. Same way. And then at the end, we want to most likely print out the sum so we can tell the user the value of sum. Alrighty, let's compile and let's run. And it prints out the sum of 0 to 10, which is 55. To see the change of sum after every single loop, we can put system.out. We could put a print statement within the for loop that shows the value of sum after every single loop has been executed. So we put sum. And since we want to show or differentiate the final sum from all the other sums, I'm going to put in a print end statement to emphasize that any other print statement after this for loop should start on a new line. And here you go. As you can see, this is the value of sum after every single loop has been executed. So the first loop, sum is 0 because, well, 0 plus 0 is equal to 0. Then it adds 1 to 0 because the value of I after the second loop is now 1. So it adds 1 to sum. And, well, the sum becomes 1 because 1 plus 0 is 1. And it continues doing that. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 5 plus 10 is 15. And it does that until it reaches I is equal to 11, and in that case, I is no longer less than or equal to 10, so the for loop ends. Alrighty, so for my final program that I'm going to do in this video, I want you to first try it out, and then I'll provide you with the solution. And basically that solution, or rather the problem, is I want you to create a program, or rather a method, that takes in two values as an input and executes the exponent of it. So we have one value as the base, one value as the power, and let's say if I give 3 to the power of 2, then it should return me 9, because 3 to the power of 2 is equal to 9. I hope you managed that. So let's first create our method. Public static void, let's name it power it, and then it's going to take in two integers, the integer base, and it's going to take in the integer power. So if someone wants to compute the value of 3 to the power of 2, integer base would be 3, integer power would be 2. And we have our curly brackets. I want a place to store the value of, let's say, 3 to the power of 2, or the result of our exponent. So we're going to declare an integer. Integer result is equal to 1. The reason why I have 1 is because when you think about it, exponents are the base multiplied by itself the amount of times the power is. So if it's 3 to the power of 2, we multiply 3 by itself twice. So 3 times 3, 9. So we declare our for loop, integer I, set that equal to 1. And as long as I is less than or equal to the power, since the power tells us how many times we're multiplying the base by itself, or how many times we're going to loop the value, or loop the loop, we're going to have that as our max value. And then after every loop has been executed, we're going to increase the value of I. And this will control the loop the amount of times that we need to get the proper exponent. Now we got to alter the result so that we get our exponent. So result is pretty much going to be equal to the old result times the base. The reason why we say base is because, well, when you think about it, let's say if I have 5 to the power of 3. If we have 5 to the power of 3, that's the same thing as writing 5 times 5 times 5, which is 125, I believe. Anyway, don't hold me on that. Anyway, 5 times 5 times 5. It's basically us multiplying the base over and over again by the amount the power is. So you could kind of say that the power is telling us to loop the value 3 times. We're multiplying 5 by itself 3 times. And we're utilizing the base to multiply it into 5. So base is what we're actually multiplying to the result, and the 3, the power, tells us how many times we're looping it, how many times we are multiplying it by itself. And then at the end, we're going to tell the user what the result is. So let's test out this method. Let's start off with something simple. Power it 3, 2. This is the same way as writing 3 to the power of 2. Now there is actually a way you can do exponents in Java. We're going to cover that in a later section, which makes it 20 times more easier than making our own algorithm. But the reason why I'm making this lesson is because I want you to get the algorithmic aspect of designing a for loop. So this is basically the same way as saying 3 to the power of 2, because we're accessing this method and then we're computing the exponent, which prints it out. And we should be getting 9. And we do get 9. And the reason why is because 3 is now sent to the base, 2 is sent to the power. So integer base is equal to 3, integer power is equal to 2. We initialize it, so its result is 1. And then it multiplies the base, the amount by itself. The base is then multiplied by itself the amount of times we say it through the power. So 3 multiplies by itself twice because the power is 2. And we could see that change when we print out. Let me actually do that after the result to show you the actual change of result. System.out.print result plus space. And then we're going to obviously differentiate with our printout line statement here. Alrighty, so this will tell us the change of result after every single loop. And there you go. So it's like, all right, let me multiply, since we have our base as 3 and a power as 2, it goes here. It's like result is equal to result times the base. So result is 1 initially, 1 times the base is 3, so 1 times 3 is 3. So the result is 3, so it prints out 3. Then it goes back here, and it's like, is I less than or equal to 2 after it increments it, so I is no longer 1, I is now 2. 2 is less than or equal to the power, which was 2 when we initialized it, so 2 is less than or equal to the power. The new result is equal to the old result times the base. So the old result was 3, and the base is, well, 3. So 3 times 3 is 9, and it prints out 9. We increment I again. Is 3 less than or equal to 2? No, it's not. So this is a false statement, and it prints out our result finally. And we could see that change even if we put, let's say, 5 to the power of 3. As you can see, we initially have result times the base. 1 times the base is 1 times 5 is 5, so it prints out 5. We increment I again. I is in fact less than 3, so 5 times 5 is 25, so result is now 25, which prints out 25. Alrighty, I is now incremented. I is no longer 2, I is now 3. 3 is in fact less than or equal to the power, which is 3. Alrighty, so we do 25 because that's the result, old result, times the base, which is 5. 25 times 5 is 125. And then this thing will be evaluated to false finally by the end of it, and it prints out 125 as the exponent of 5 to the power of 3. And that wraps up our video on for loops. It's a very powerful tool, just like while loops, just like anything we're doing in Java. But the difficulty that comes with for loops is keeping track of the loop control variable and making sure that you're looping it the correct amount of times. You don't want an extra loop, but you also don't want the loop to be going on forever. So these are the things that you have to keep in mind when you're doing for loops in Java.